The universe is vast and mysterious, an endless expanse that stretches beyond our imagination. It is a place where time and space intertwine, creating a cosmic tapestry that has fascinated humanity for millennia. It is filled with wonder, a celestial dance of light and darkness, where galaxies swirl and stars twinkle like distant beacons of hope. Each star, a burning ball of gas, tells a story of creation and destruction. One of its most spectacular events is the birth of a star. This process, known as stellar formation, is a complex and awe-inspiring phenomenon that takes place over millions of years. Stars are born in clouds of gas and dust, known as nebulae. These nebulae are the cradles of star formation, where the raw materials of the universe come together to create new celestial bodies. We call these clouds nebulae. They are vast, colorful regions of space, often illuminated by the light of nearby stars, creating breathtaking cosmic vistas. These nebulae are like giant stellar nurseries where new stars are born and begin their journey through the cosmos. Within these nurseries, the conditions are just right for star formation. Inside these nurseries, gravity pulls the gas and dust together, causing the material to clump and coalesce. This process, known as gravitational collapse, is the first step in the birth of a star. The material clumps together, getting denser and hotter. As the core of the clump heats up, it begins to glow, marking the formation of a protostar. Eventually the core becomes so hot that nuclear fusion begins. This is the process where hydrogen atoms fuse to form helium, releasing a tremendous amount of energy. Hydrogen atoms fuse to form helium, releasing tremendous energy. A star is born. This new star will shine brightly, illuminating the surrounding nebula and contributing to the cosmic dance of light. These newborn stars come in different sizes, each with its own unique characteristics and life cycle. Some stars are small and faint, while others are massive and bright. Some are small and faint, like red dwarfs. These stars burn their fuel slowly and can live for billions of years, providing a steady, gentle light. Others are massive and bright, like blue giants. These stars burn their fuel quickly and have much shorter lifespans, but they shine with an intense, brilliant light. The fate of a star and its impact on the universe depends on its size. Massive stars may end their lives in spectacular supernovae, while smaller stars may quietly fade away. Each star, regardless of its size, plays a crucial role in the ongoing story of the cosmos. A star's life is a constant battle against gravity. From the moment it is born, gravity exerts a relentless force, pulling everything inward towards the core. The immense inward pull of gravity wants to crush the star, compressing it into a dense, compact object. This force is so powerful that it can cause the star to collapse under its own weight. But the outward pressure from nuclear fusion pushes back. Deep within the core, hydrogen atoms fuse to form helium, releasing a tremendous amount of energy. This energy radiates outward, counteracting the force of gravity. This delicate balance between the inward pull of gravity and the outward pressure from nuclear fusion keeps a star stable for millions, even billions of years. It's a cosmic dance that ensures the star remains in equilibrium. Smaller stars, like our sun, live long and peaceful lives. They burn their fuel slowly, shining steadily for a very long time. These stars can last for tens of billions of years, providing a stable source of light and heat. They burn their fuel slowly, shining steadily for a very long time. This slow and steady consumption of fuel allows them to maintain their stability and continue shining brightly for eons. But massive stars live fast and die young. Their enormous size means they have a much stronger gravitational pull, which forces them to burn their fuel at a much faster rate. Their enormous gravity forces them to burn their fuel much faster. This rapid consumption of fuel leads to a shorter lifespan, often just a few million years. As a star runs low on fuel, its core begins to contract. The balance between gravity and nuclear fusion is disrupted, causing the core to collapse inward under the force of gravity. The outer layers of the star expand, becoming cooler and redder. This expansion is a result of the core's contraction, which causes the outer layers to swell and cool. The star transforms into a red giant, a cosmic elder nearing the end of its life. In this final phase, the star's outer layers are shed, leaving behind a dense core that will eventually become a white dwarf, neutron star, or even a black hole. When a massive star reaches the end of its life, it goes out with a bang, a supernova. This is one of the most powerful explosions in the universe. It's a spectacular death that sends shockwaves rippling through space. The supernova happens when the core of the star can no longer withstand the crushing force of gravity. The core collapses in on itself, triggering a runaway nuclear reaction. This releases an unimaginable amount of energy, blasting the star's outer layers into space. For a brief moment, a supernova can outshine an entire galaxy. It's a brilliant display of cosmic fireworks. But more importantly, it's a crucial event that shapes the universe around it. Supernovae are not just destructive forces, they are also cosmic creators. In their fiery death throes, massive stars forge heavy elements, the building blocks of planets and life itself. Deep within their cores, stars create elements like carbon, oxygen, and iron. These elements are essential for life as we know it. But when a star explodes as a supernova, it scatters these elements far and wide across the cosmos. This stardust drifts through space for millions of years. Eventually it becomes part of new stars, planets, and even us. The iron in your blood, the calcium in your bones, they were all forged in the heart of a dying star. Supernova explosions don't just spread elements across the universe, they also trigger the birth of new stars. The shock waves from a supernova can compress nearby clouds of gas and dust. Remember those stellar nurseries we talked about? The shock waves from a supernova act like a cosmic kick, causing these clouds to collapse. This jumpstarts the process of star formation, creating a new generation of stars. It's a beautiful cycle of cosmic death and rebirth. Supernovae, in their destruction, paved the way for the creation of new stars and planets. Section 6. Shaping galaxies, the force of a supernova. Supernovae are not just important for individual stars, they also play a crucial role in shaping entire galaxies. Their powerful explosions send shockwaves that travel for thousands of light-years, influencing the structure and evolution of galaxies. These shockwaves can trigger the formation of new stars. They can also expel gas and dust from a galaxy, regulating its growth and evolution. Without supernovae, galaxies would look very different, and life as we know it might not exist. Supernovae are essential for distributing heavy elements throughout a galaxy. This ensures that new stars and planets are enriched with the building blocks of life. Section 7. Neutron stars and black holes. Echoes of a supernova. In the vast expanse of the universe, stars live out their lives in a spectacular fashion. One of the most dramatic events in the life cycle of a star is the supernova explosion. This cataclysmic event marks the end of a star's life, but it also heralds the beginning of something new and equally fascinating. After a supernova explosion, the core of the massive star is left behind. This remnant core is incredibly dense and hot, a stark contrast to the vastness of space around it. The fate of this core depends on its mass, leading to the formation of some of the most intriguing objects in the cosmos. This core, incredibly dense and hot, becomes one of two fascinating objects, a neutron star or a black hole. The transformation process is a testament to the incredible forces at play in the universe, compressing matter to unimaginable densities. Neutron stars are incredibly compact, with the mass of our sun squeezed into a sphere the size of a city. Imagine all the mass of our sun, which is about 330,000 times the mass of Earth, compressed into a sphere just about 20 kilometers in diameter. This makes neutron stars one of the densest objects in the universe. They spin rapidly, emitting beams of radiation that sweep across the cosmos like cosmic lighthouses. These beams can be detected by radio telescopes on Earth, and they provide valuable information about the properties of neutron stars. The rapid rotation and intense magnetic fields of neutron stars make them fascinating objects of study. If the core is massive enough, it collapses into a black hole. This collapse is so complete that it creates a region of space where the gravitational pull is so strong that not even light can escape. This is the birth of a black hole, one of the most mysterious and powerful objects in the universe. Black holes are regions of space-time where gravity is so strong that nothing, not even light, can escape. They are formed from the remnants of massive stars that have ended their life cycles in supernova explosions. The gravitational pull of a black hole is so intense that it warps the fabric of space-time itself. They are mysterious objects that continue to intrigue and puzzle scientists. Despite their elusive nature, black holes are key to understanding the fundamental laws of physics. Researchers use advanced technology and theoretical models to study these enigmatic objects, hoping to unlock the secrets of the universe. Section 8. Supernovae, essential to our existence. Supernovae are not just distant cosmic events. They are intimately connected to our existence here on Earth. The elements forged in these explosions are the very building blocks of our planet and our bodies. Without supernovae, the universe would be a very different place. It would be a much simpler universe, devoid of the heavy elements needed for planets and life. So, the next time you look up at the night sky, remember this. The atoms in your body were once part of a star that exploded millions of years ago. We are all made of stardust. Section 9. Our cosmic connection, looking up in wonder. The study of supernovae allows us to trace our cosmic lineage. It reminds us that we are not separate from the universe, but an integral part of it. We are connected to the cosmos in a profound and meaningful way. As we continue to explore the universe, we gain a deeper appreciation for the power and beauty of these cosmic events. Supernovae, in their death throes, enrich the universe and create the conditions necessary for life to arise. So let us continue to look up in wonder, to explore and to learn, and to celebrate our place in this vast and incredible universe.